Welcome to this video, which will guide you through correcting the detection accuracy of the flow rate value for the FDH series clamp-on ultrasonic flow meter. The objectives for this video are to introduce the common causes of detection inaccuracy for ultrasonic clamp-on flow meters, and then discuss how correcting detection accuracy is easy to do for the FDH series. First, we'll discuss some common reasons as to why you would see inaccuracies in a clamp-on ultrasonic flow meter. If the flow inside of the pipe is very turbulent, the flow rate reading on an ultrasonic flow meter will typically begin to fluctuate. This is because ultrasonic flow meters detect the speed with which the liquid is traveling through the pipe and multiply this speed by the internal cross-sectional area of that pipe. This is how they arrive at a volumetric flow rate. If the meter detects that the fluid speed is fluctuating due to the turbulence, the flow rate reading from the meter will start to fluctuate as a result. If the sensor does not know the correct internal cross-sectional area of the pipe, then as a result, the flow rate reading will be inaccurate. The last thing that we'll discuss is the ultrasonic properties of the pipe or fluid. The properties in question are the ultrasonic velocity of the fluid, the ultrasonic velocity of the pipe material, or the kinematic viscosity of the liquid. It's important that the sensor knows the properties of the fluid or piping it's being used on to ensure optimal accuracy. Now that we know some general information about why a clamp-on ultrasonic flow meter might become inaccurate, let's see how the FDH series solves these problems. For issues with turbulence, there are two actions to take. The first thing we could do is increase the response time of the sensor. This will help the sensor average out what it sees inside of the pipe, which is perfect for making the flow rate reading steady when the flow is very turbulent. You can find the response time setting by pressing the mode key, selecting settings, selecting detection settings, selecting flow sensor, and then adjusting the response time here. A longer response time will average out the flow rate reading more than a shorter response time, which is useful for rapid turbulence. The second thing to do is to maximize the amount of uninterrupted straight piping before and after the location where the flow meter is mounted. The more straight piping you've got going into and then out of the meter, the more laminar the flow will be, which is ideal for accuracy. The best way to correct the flow rate on the FDH series is by performing a span adjustment. This involves comparing the flow rate, or accumulated flow, the sensor measures to a known value, such as a reference flow meter or a known volume of liquid that just passed through. Although this method requires testing, it is nice because you do not need to know any details about the pipe dimensions or ultrasonic properties of the piping or the fluid. As long as you're able to correctly identify the flow rate or the volume of flow that passed through the pipe, you can perform a quality correction to the flow rate. Let's talk about an example of this process. If I've got an FDH flow meter and I want to make sure that it's reading accurately, I can either compare the flow rate on the meter to another flow meter on the same line, or I can compare the accumulated flow value on the meter as I fill up a 5-gallon bucket. Let's say I fill up the bucket and I know that 5 gallons just went through, but the FDH only reads that 4.9 gallons passed through. I can calculate the span I need to enter by dividing the actual amount, or 5 gallons, by the FDH's measured amount, which is 4.9 gallons, and then enter this value into the span adjustment setting to make that flow rate more accurate. One final note on this method is that the quality of the correction is only as good as the quality of your flow rate or volume measurement. It might be a good idea to conduct multiple tests and average out your results to arrive at the best possible span adjustment value. If you cannot conduct any tests for the flow rate or the volume traveling through the meter, you can still correct the flow rate value. We spoke before about how the cross-sectional area and the ultrasonic properties of the fluid or pipe can play a role in the accuracy, and the FDH lets us enter in all of this information. From the current value display screen, press the menu key, select Settings, select Detection Settings, select Flow Sensor, navigate down to Additional Settings, and then select Additional Settings. Now you can navigate down to enter the exact outer diameter, the exact thickness, the pipe or fluid ultrasonic velocity, and the kinematic viscosity. Inputting these settings to the best of your knowledge will help increase the accuracy.